All right, so let's begin with section 4.2. As I mentioned in 4.1 when we were looking at distance time graphs, I had mentioned that we were going to go beyond what we had just said in terms of talking about how steep a line is, right? Very steep, not steep. We're going to go beyond that in this lesson and actually give a numerical value to the steepness of a line. All right, we're going to still concentrate on distance time graphs. Okay, and we are going to learn how to calculate an actual value for the steepness of a line. To do so, okay, I'm going to ask you the question, or ask the question, how can we measure the steepness of any line? Like, what way can we come up with where we can actually get a numerical value for how steep a line is? Well, let's consider a staircase. All right, so let's say we had this staircase here on your right, and we had to come up with a way to determine how steep that staircase is. As we know, there's different staircases with different levels of steepness. Okay, we can actually describe the steepness of the staircase by asking ourselves this point right here. For every step to the right on the stairs, how high do we climb? So every movement to the right on the stairs, how high do we need to go up to get to the next step? Okay, it is the exact same for linear relationships on a graph, because if you look at the staircase, I can actually draw a line connecting the tips of each step, or the edges of each step, and you can see that a straight line would be formed there. And if we can break up our line into almost these little points here, just like we would as if there was a staircase, we would also be able to calculate how far right we needed to move to get to our next point and how far up we needed to move to get to that point. So we'd be able to do that just like we do with the staircase with a linear relationship. And the terminology that we use for that, let me just undo some of what I have here. The terminology that we use is, that's called our run. And this, when we go up like in this way, that is called our rise. So if we pick 2 points on our line, let's say this point and this point on this line, right? We can find out what the run is, or the horizontal distance. Okay, so the run is your horizontal distance, and your rise would be your vertical distance. So we could figure out the horizontal distance and the vertical distance, and what we're actually going to do is divide them, and that is going to be what we call our measure of the steepness of a line. We're going to do something called the rise over run. And so here it is. Rate of change, or the steepness of the line, or the slope, which all mean the exact same thing. All right? So the word steep, when I say how steep a line is, I'm referring to the rate of change or the slope of the line, or specifically in a distance time graph, it is actually known as the speed. All right? So in a specific situation like our distance time graph, the rate of change is actually the speed at which you're going. That's the rate at which you're going. All right? And so we are going to calculate it by doing rise divided by run. And again, if I go back to that staircase here, we're going to pick 2 points, and we're going to find the run distance, or the horizontal distance between the points, and then the vertical distance between the points, or the rise. All right? Let's actually see how that looks in an example. We have several lines here in a distance time graph. I'm actually going to find the rate of change, or the slope, or the speed in this case, because it is a distance time graph. When we find the rate of change, it'll be a speed. I'll find it for this line. I'll call it line 1. I'll find it for this line and I'll call it line 2. And then I'll even do this special situation here, line 3, that horizontal line, which we already know has a rate of change of 0, but we're going to see why it's a rate of change of 0 when we do our rise over run calculation. Okay, so let's do that. Now what I've written here are some points to follow when finding the slope or rate of change or the speed in a distance time graph. Okay, so step 1 is pick any 2 points on the line. All right, so let's pick any 2 points on our line. Let's pick this one and this one. Notice what I had mentioned here. Look for points that go through crosshairs on the grid. What do I mean by crosshairs on the grid? Well, let's take a look. By crosshairs, I mean don't pick a random point that's like in the middle of a cell here, because it'll be too hard to kind of guess what the x coordinate and what the y coordinate are. Instead, make it easier on yourself, all right, and pick something that goes through these crosshairs. See how, that's what I mean by crosshairs, where these grid lines meet each other, all right? Pick points that go through those crosshairs, and you can pick any 2 points. So you didn't have to just pick these 2 points. I could have picked this point here, and I could have stayed with this point here, or I could have done, sorry about that, or I could have done, this point and this point. It doesn't really matter which points you pick, as long as they're 2 points that go through crosshairs and they're easy to work with because of that. All right. So because I've redrawn this in here, this point and this point, I will stick with these 2 points. Now let's go back down to step 2. It says draw a right angle triangle connecting the 2 points. And I've done that already. Here, I have drawn this right angle triangle. A right angle triangle is a 90-degree angle triangle connecting the 2 points. The reason why we want to draw that little triangle connecting the points, it will make it easy for us to observe the run, the distance that the run is, and observe the rise, the distance that the rise is. So we're going to observe that in a second. We've drawn the triangle. So we've picked our 2 points. We've drawn the triangle. Let's go down to step 3. Determine the rise distance on your triangle. Let's do that right now. The rise distance. So how much of a rise is it from here, this point here, to this point here? We need to calculate. So let's see, if I look at my scale, take a look at your scale on the y-axis. It's going by 5s. So for every grid mark that I go up, it's worth 5. So starting from here, all right, I'm going up 5 from here to here, then another 5, I'm at 10, 15, until I get to 20 up there. So this whole line here, my triangle here, that rise part of my triangle, is worth 20, and my units is meters. So it's worth 20 meters. I went up 20 meters. And again, it's because I'm looking at my scale. It's a classic mistake to just count the grid marks and say, oh, this is 1, 2, 3, 4 grid marks. That means my rise is 4. That's not the case. You always have to look at your scale. All right, so always reference your scale here and see that, oh, I'm going by, each grid mark is worth 5. So I'm going 5, 10, 15, 20 in total. Let's take a look at my rise, my run. You can see the scale for our x-axis, or where I'm going to be counting my run, is different than my y-axis. It's actually going by 0.5s, right? It's actually going by 0.5s. Each grid horizontally is worth 0.5, or half a second. So from here to here, I have 0.5, 1, 1.5, 2 seconds. So from 2 to 4, which makes sense. Okay, so from 2 to 4, that's my run, which is a total of 2 seconds. Sorry, I know it's getting a little bit sloppy in there. All right, so my rise is 20 and my run is 2. Let's take a look at our steps. We found the run, so we finished that step. Now it says that we need to divide the rise over run to determine your slope or your rate of change, or in this case, our speed, because it's a distance time graph. All right, so let's do that. We're going to do rise over run. So I'm just going to scroll down here. And I'll do it in the blank space here. So our rate of change and this is for line 1, by the way. Our rate of change, or our speed in this case, is equal to the rise over run, which is 20 meters divided by 2 seconds. That equals 10. Now, be careful here. You've got to keep your units. Because we have meters over seconds, we are going to keep that and say that our slope or our speed is 10 meters per second. And that is going to be our final answer for the measure of the steepness of that line. Okay? So if I go back to the graph, this line here, this entire line, and it doesn't matter which 2 points you picked, you would have got the exact same answer. Trust me, you could have picked any 2 points along this line and you would get the exact same answer. You would get 10 meters per second. All right. Number 2 is going to be the exact same. So our second line here is going to be the exact same. The difference is from our second unit, we know that this is going down and to the right. So instead of it having a positive rate like our previous line did, it's actually going to have a negative rate. Okay, it's a decreasing linear relationship, just like we did in Unit 2. So it's going to be negative. It's going down and to the right. And I'm just going to keep that in mind. All right. So step 1, and actually I will erase. I'll erase everything I had previously so we can kind of make this a little bit neater. Okay. So I'm going to pick, step 1 is pick 2 points. I'm going to pick this point, and I could pick this point here. It's going through crosshairs. All right. I can pick that point, no problem. But I'm just going to pick this one down here because it'll allow me to draw a bigger triangle and it'll be a lot neater. All right. So those are the 2 points that I'm picking. Next is draw my rate triangle. It's got to be a 90-degree angle triangle, like so. All right. So it's got to be a 90-degree angle triangle. I'm going to write out my rise, and I'm going to erase here to make this a little neater. And I'm going to write out my run. All right, so my rise, let's calculate it. Remember, we're going by a scale of 5s, right? So we're going, each grid is 5. So start at 0 at the bottom, 5, 10, 15, 20, 25, 30, 35, 40. My rise is 40 meters. My run, remember, each grid is half a second. So my run is actually from here to here. It is actually just 1 second. By the way, hopefully you're starting to anticipate here that the previous line that we found, the slope was 10 meters per second, do we expect that this slope will be steeper? I think you should say, just by looking at it, yes. And if it's steeper, let's look at what that means for the value that we get. All right, so it's a steeper line. All right, so our next step now is to do the rise divided by the run. All right, so I'm going to do down here for line 2, my speed or my rate of change. It's a little sloppy, I'll make that better. Is my rise over run. Which is 40 meters divided by 1 second. And I don't want this to look like a 5. Okay, so I'll do my best to draw it as an S, which is 40 meters per second. All right, and I'm going to box my final answer there. That is my speed. And as I said, we expected this to be a steeper line than the previous one we found. So my answer here was 40, and look at my answer above was only 10. And that makes sense. The steeper the line, the larger that value is going to be. But remember what I said up here. This is now a negative slope, or it is a negative rate. It is a decreasing relationship because the line is going down and to the right. So I am going to make my slope, make sure you do this, it is negative 40 meters per second. It is going down 40 meters for every second that goes by. That's what that means. And let's see. That is true, right? It is going down 40 meters for every second that ticks by. All right, now I promised that I would also do this kind of special scenario here, number 3. Let me erase everything else to make this look cleaner here. All right, the reason why we know this will end up being 0, or line 3. All right, the reason being is, how can you draw a triangle between these 2 points? I mean, all I see here, there is a run, right? Our run is still 1 second, but what is our rise? There is no rise. It is 0. It did not go up or down anything. So when we go and throw this into our formula of rise divided by run, I'm going to start referring, instead of writing out rate of change, I'm going to write out ROC. Okay, everybody? So ROC instead of rate of change is equal to rise over run. But remember, our rise was 0 and our run was 1. On your calculator, 0 divided by any number is always 0. And that is why our rate of change for a horizontal line is 0, because you're always going to have a rise of 0 for a horizontal line, right? You're not going up or down. And so that will always be the case. For any horizontal line, the rate of change will always be 0. All right, so there you have it. Make sure that when you are in your homework questions finding the slope or the rate of change, or in distance time graphs, the speed, follow these 6 steps, right? Make sure that you follow these 6 steps until you've practiced it enough